Hi and welcome everyone to this webinar called Solar Power for Off-Grid Cabins, Getting Started. My name is Niklas Rusche. I work for the FNQ LSDI, the First Nations Quebec and Labrador Sustainable Development Institute. In this webinar, we want to talk about solar photovoltaics for off-grid sites. Photovoltaic means we produce electricity directly with our solar panels, so it's not solar thermal where we produce hot water. And we're talking about off-grid sites, so cabins, RVs, hunting camps, nothing that's connected to the Hydro-Quebec grid. First, I want to talk about the thing we want to learn to avoid using, which is our fossil fuel generator. Fossil fuel, that can mean diesel, that can mean propane. In most cases, it's probably gasoline. There's a couple of advantages, of course, that generators offer, and that is they have a high power output, they are weather independent, and they are relatively inexpensive to buy compared to solar power systems. But of course, whenever I use them, they consume fuel. The fuel transport and manipulation is a disadvantage. I need to do regular maintenance, so every 100 hours usually. It has a high standby consumption, it's noisy, it's polluting, it contributes to global warming, also known as climate change, and it is extremely wasteful. Let me explain. The fuel that I'm pouring into my generator is going to be transformed by the generator into 80% heat and 20% electricity. And that's the best case. Let's say if I run my generator at full power, let's say it's a 2000 watt generator and I'm running a 1800 watt, let's say a toaster oven. Then my generator is 20% efficient. That means 1/5 of the energy that I put into it gets used. However, if my generator is only supplying power to, let's say, a small fridge that uses 50 watts, then I'm not losing 80%, I'm even losing maybe 95% of the energy. And that's because the generator has a high standby use. It will always consume a certain amount of gasoline, even when I don't plug anything into it. Let's look at where the energy in your cabin usually comes from. It comes from gasoline, it comes from propane, and it comes from wood. All these are chemical energy carriers. But gasoline and propane come from fossil fuel, and wood, of course, usually comes from around your cabin. So the trees, when they grow, absorb the greenhouse gases in the atmosphere, and they are released when you burn them. So it's a circular economy. And it's very local. So wood is the sustainable energy source that we can use at our cabin. So the gasoline we pour in our generator, and we have learned that the generator turns it into, yes, electricity, but also a lot of heat and exhaust. And with this electricity, we can run our different devices in our cabin. Usually for cooking, we use propane, and that's because using electricity to do boring tasks like cooking, that's of course not a good idea, and even worse, it's when you want to heat your cabin with electricity that comes from a generator. That's honestly the biggest no-no you can do. It's a giant waste of energy because you use 5 times as much energy compared to using a diesel heater or a propane heater. Now, we can also use propane for heat, of course, but this is going to be expensive in the long run. And we can use wood to cook, which of course is the ideal because we learned that wood is a sustainable energy carrier. So we want to do this if we can. In some older cabins, yes, we use gasoline for a generator, but usually only when we want to run certain devices such as a TV, and the lighting and the freezer or fridge are run by propane. For those who know it, propane lighting is really not fun to use. It's complicated, it produces a lot of heat, and it's not very practical. Propane fridges are okay, they work okay, and they are fairly indestructible, but they will use propane, and if you let them run all season long, they'll use a lot of propane, which of course produces greenhouse gases and a lot of cost. What we really want to do is have a different energy source, which is the sun. The sun's radiation can be transformed into electricity with our photovoltaic panels. PV stands for photovoltaic. And this electricity can be put into batteries and then supplied to the devices we want to use. Of course, we'll keep our fossil fuel generator just as a backup in case we have a couple of cloudy days where the solar panels don't produce enough, or we have a special occasion, let's say a construction site, where we use a lot of power temporarily. It doesn't make sense to size your solar system for the construction project. You want to size your solar system for everyday use. Now let's get to the topic, off-grid solar power. First, let's start with some disadvantages. It's more expensive to buy than a fossil fuel generator, and usually you have less energy available just because you have to produce it yourself and you can't buy it in chemical form at the gas station. But that also means that I have no fuel cost, I don't need to transport big amounts of fuel, I have very little maintenance to do, I have no standby consumption, or very little, we'll get to that, no noise, no pollution, a usually very long lifetime of the panels and the electronic components, and I don't contribute to climate change. What's the anatomy of a solar PV system? So first off, I have the photovoltaic panels. What they do is transform the sun rays into electricity. And then I have a cable that goes inside, and inside I have something that I call the batteries and company, because it's the batteries and it's also a couple of other devices that can produce electricity we want to use. And that can be either in 120 volts, so that's the voltage we usually have in our houses. Then we can use 12 volt devices, so that's everything you can plug into a cigarette lighter plug in your car. And then another form is USB, which is more and more used to power all sorts of devices. This is usually 5 volts, but it's a bit more complicated, so let's just keep it at USB. Just in case it isn't clear, let's look at how a solar system works. First, I have the sun that shines on my panels. It produces electricity that charges up my batteries, and the batteries supply power to my devices. At night, the power that's stored in my battery will supply power to all the devices, and if I have multiple cloudy days, my batteries might run out of power, and in this case I can always use my generator as a backup to charge up the batteries that can still continue to provide power to all my devices. And usually when my system is well designed, it takes, let's say, 1 to 2 hours to charge up my battery, and then the battery can supply power to my devices for the rest of the day. So big advantage, I only need to run my generator at full power for 1 to 2 hours, then it's done, I can turn it off even when I don't have any sun. Ideally, the generator doesn't run at all because I want to use the sun as much as possible. All right, let's get into solar panel types. Here I just want to talk about the types that exist that you can buy, and later on we're going to talk about how you can install them. First, I want to say that the technology inside of the panels is not that important for us. I know you've probably heard about polycrystalline, monocrystalline. Just a heads up, all the panels that you buy today are monocrystalline. And then there's a couple of other technologies and advancements that are really not that important to us, because if we buy a 400 watt solar panel, it's a 400 watt solar panel. What happens inside is not that important for us. So let's look at portable PV panels first. This here is the older style. It's like a briefcase. The advantage is that it uses real solar panels. So you have this glass surface and you have an aluminum frame. The advantage is that it's pretty durable. Aluminum and glass will last a long time, but of course the panel is not very light and not very space saving. Then we have the so-called flexible panels. These are based on a plastic surface. The solar cells, which are these blue squares, are integrated into the panel, and the problem is that the panel itself is flexible, but these blue squares are not really. So what happens is they'll get microfractures when you bend the panel too much. So these panels won't last a long time, maybe a couple of years, but it's nothing compared to glass and aluminum panels that will last 25 years and more. One way to mitigate this is using smaller plastic panels and make them foldable in the middle, like this one over here. This is usually what's being used today by manufacturers of solar power stations that sell panels with their products. These panels are pretty expensive, and as I said, they won't last as long as glass and aluminum panels. Now let's look at real solar panels. These solar panels, as I mentioned, they have an aluminum frame that protects the glass and also is used to attach the solar panels to a structure. As you can see here, we have different sizes. These are 100 watt solar panels that can be bought online, and they are still small enough to be shipped. But the really best bang for the buck you get when you buy bigger panels, like 300, 400, 500 watts. And you see these are fairly big. The reason they are the best bang for the buck is because they are being mass produced. There is a big economy of scale just because there are so many of those that are being produced worldwide. The prices have fallen a lot in the last 10 to 15 years, and they have the best power to price ratio. So when you buy solar panels, you always want to look at the dollar per watt. So for example, if a 400 watt panel costs, let's say $200, I pay 50 cents, $0.50 per watt. One technology that is indeed important are bifacial solar panels. They are really good for winter use. We'll explain this later on. Where do you buy these panels? The small panels you can buy online, which gives you the best prices. You can buy them at Canadian Tire, but be aware that the prices are usually not the best at the big box stores, and also the staff can't help you with technical problems. So you're better off to buy them at a dedicated dealer. I'll put a link to a map of solar installers and vendors in Quebec in the description. When you buy a solar panel, there's a couple of numbers you should look at. And the most important one, of course, is the rated power Pmax. Be aware that if you buy a 100 watt panel, usually on most days it'll only produce 80% of its maximum power. For a 100 watt panel, that would be 80 watts. So don't be disappointed. However, when it gets very cold and very sunny, then your Pmax, your power, can be even higher than what's written on the panel. It can go up to 120, but that doesn't happen very often. The next number we have to look at is the open circuit voltage, VOC. It's very important for compatibility. So it tells us if we can plug the panel into a solar power station. Usually they have a limit maximum VOC that we shouldn't go above. It gets a bit more complicated because one thing we have to know is solar panels work really well when it's cold. So we have to calculate the maximum open circuit voltage in our panels by multiplying it with 1.25. So basically we add 25% and that gives us 22.5 times 1.25, and the result is 28.1 volts. So for this panel, our actual VOC is 28.1 volts. And this is what we have to use when we want to check for compatibility with, for example, solar power stations. Now let's go inside and look at our batteries. So for your battery setup, you basically have two options. You can have a modular system that's usually hand-built with distinct components and the batteries. And you can have an integrated system, which is also called a solar power station. Sometimes it's called a solar generator, a portable power station. And these are systems that have everything integrated and that has some advantages, but also some disadvantages. Let's look at this. There are different brands, of course, but they all are relatively similar in that they have all USB outputs. You have USB-A and USB-C outputs. Here they are there, and up here they are usually hidden here. Then you have 120 volt outlets. For this model they are in the back. Here you have the 120 outlets. Here this is a bigger model where you have 6 of them. They are behind these plugs. They also have a screen that shows you where the battery is at, if it's full, if it's charging, how much power is coming in, how much power is going out. And then you can charge these either with a normal 120 volt cable, so you can plug them into a wall, and you can also plug them into a generator to charge them up. And the other option is you can plug them either into a cigarette lighter outlet, which is usually very slow, but you can plug in solar panels, and this is why these things are called solar generator. They, by themselves, you cannot put them in the sun and expect them to recharge. They need solar panels. The way this works is you need, of course, a solar panel. Then usually these devices come with a cable that plugs into the solar power station on one side, and on the other side you'll find these so-called MC4 connectors, which are basically the standard connectors for every solar panel that you can buy. These are called barrel plugs. They are a bit less common now. They are not the ideal solution. More often today you'll find these connectors that are called XT60, and they are great connectors and can transport more solar power into your power station. What's important here? We remember that our solar panels have a certain open circuit voltage that has to be adjusted for our cold temperature, and here is where that comes into play. Usually where you can plug in your solar panel, you'll find a voltage indication. So here it's 12 to 40 volts. If we remember, our solar panel had usually 22 volts, but we had to increase the voltage because of the cold temperatures we live in to 28 volts. And we see that these 28 volts are still below the 40 volt maximum of our connection here. So we can plug this solar panel into our solar power station. Bigger solar power stations can accept up to 100 volts, so you can connect bigger panels. That brings us to the simplest solar power setup that you can have. It's based on a solar power station. You'll mount solar panels on your roof. You'll likely need an extension cable because this cable that comes with the power station is not very long, usually 2, maybe 3 meters. So you usually need an extension cable, which is called an MC4 extension cable. And if you want to plug in multiple panels, usually you also need a branch connector or Y connector. These panels will recharge your power station in normal conditions when there's sun. If there's no sun, or if you have a higher than usual consumption, then you can use your generator to recharge your power station, and that usually takes 1 to 2 hours. Your power station will then supply electricity to all the devices. You don't need to unplug anything. If you turn on the generator, it will charge the power station and at the same time supply electricity to all the devices that are plugged into the power station. So that's really the easiest system. This thing here is called a port plug, and it's basically only an elegant way to bring your extension cord through the wall. This, on the other hand, is a custom-built system. So here you find different components like the solar charge controller. This is a battery charger. This is the inverter. These are different breakers that protect the system. And you can find a lot of cables. And down here you will find the most important part, the 2 batteries. Usually you don't have to build all this up here by yourself. You can go to a solar professional and they will build this for you on a piece of plywood, or in this case a piece of plastic panel, or sometimes it's a panel made of aluminum. This you can install at your cabin and connect the batteries and everything should work. And of course you also have to connect the solar panels. So how do these two compare? Custom modular systems are modular, hence the name. Components can be replaced, so we can improve components, we can replace them, we can add others, we can combine different brands. So this is usually better for larger installations, and it has a longer lifespan. Not only because the parts last longer, but also because we can replace components and we don't have to throw the whole thing out when something doesn't work. But they can be more expensive. Even if we assemble it ourselves, and don't underestimate it, proper cabling jobs are hard to do. It's still more expensive than a solar power station with the same specifications. Solar power stations, in comparison, everything is integrated. They are very compact. They're easy to transport. That's relative. Bigger solar power stations are quite heavy, up to 50 kilos. They're easy to connect. You just have to plug everything in. They are also foolproof, in the sense that the battery will protect itself when it's too empty, or when it's too warm, or when it's too full, or you take too much power out of them. So that's very important. And the downside is they are difficult to impossible to repair. We don't know if the company that makes them today will still exist in 5 years or 10 years. This brings us to my favorite topic, energy consumption and energy efficiency. Why is this important? Well, energy efficiency means either doing more with the same or doing the same with less. And that's really what we're interested in here. We want to do the same with less. So for example, if we use LED lighting, we can have the same light, the same amount of light, but we use much less energy to have the same result. So what are the devices that consume energy at our cabin? There's lighting. There are electronics like cell phones, televisions, radios. There's cooling, fridges and freezers, very important. Other things like battery chargers or CPAPs. CPAPs are quite important for those who need them. And then there's kitchen appliances like stovetops, coffee makers, water kettles and microwave ovens. And I have to say right away, everything that heats uses a lot of energy. And then there's heating, that could be space heating or water heating, and it usually takes so much energy that we can't do it with an off-grid solar power system. Usually we have to use either wood or propane to do it. Let's look at lighting. These old incandescent light bulbs are very power hungry. These are a little better, but they have a downside, which is they contain toxic mercury. So when they break, that's a health concern. And there's really no reason, because LED lamps are really affordable and you'll find them everywhere. A special way to be really efficient is to use 12-volt light bulbs. That could be light bulbs like this or other LED lights that work directly with 12 volts. This way you can use the electricity directly from your batteries and you don't need to use an inverter that uses also a lot of power in the background. Then we have electronics. Televisions, here you have to look at the model you have, but you also have to look at the size. Bigger televisions take much more power. So the smaller your television is, usually the less power it uses. Laptops are usually built to be fairly energy efficient, so charging them is not what will drain your batteries. Your cell phones are fairly efficient, so honestly, it's peanuts compared to everything else. Don't worry about it. You can charge your cell phone as much as you want. Radio telephones, CB radios, something like this, usually doesn't take a lot of power, but it can happen. So you have to check, because the models are all different. What really takes a lot of energy are gaming consoles. So PS5, Xbox, these modern gaming consoles with really powerful graphics cards, they will use a lot of power. So be careful with those. And then there's Starlink, which usually uses a lot of power, especially when it's turned on all day long. What I really recommend for Starlink is turn it on only when you need it and then turn it off again. If you have to have it on for longer periods, try to find energy saving settings in the app. Refrigeration is one of the bigger energy consumers as your cabin. There are different options. There are propane refrigerators. They are expensive to buy and expensive to run because you have to buy all the propane. They require regular maintenance. They produce humidity that's usually put out in your cabin. And in the same category are triple energy fridges. What do I mean by that? Usually in RVs you find fridges that will run on 12 volts and 120 volts and propane. These are actually only propane fridges where the flame in electric mode is replaced with an electric heater. That makes them really, really, really inefficient. So don't use them in electric mode. Then you have 12-volt fridges and freezers. First, let's look at thermoelectric ones. These are usually fairly cheap. You can identify them by the fact that they advertise to be able to cool and heat. Their cooling function is really inefficient. They will drain your battery if you use them as a fridge. And on top of that, they are not really very powerful in terms of cooling performance. The only devices that can create cold in an efficient way are compressors. So you have to have a compressor fridge, and there's 12-volt compressor fridges that are very efficient, but they are a niche product. So very small quantities are being produced, and that makes them relatively expensive, like 3 or 4 times more expensive than a comparable 120-volt fridge. The other option you have off-grid are domestic refrigerators. They are much less expensive than 12-volt fridges, and unfortunately they are also less efficient than 12-volt fridges. But that's usually okay, because you can spend the money you save on the fridge and invest it into more solar panels and more batteries. One thing to keep in mind is that you need a really high quality inverter that has a low standby consumption. And the fridge itself has to be efficient too. To find out if a fridge is efficient or not, you should look at the Energy Star logo, and you'll find this usually on these Energuide cards in the corner. And you can also look at the annual kilowatt hour consumption, and that should be below 400 kilowatt hours per year. Here's some other advice what you should pay attention to when you buy a fridge. 2 small fridges are not really worth it. The small hotel room fridges have really thin insulation, and they usually consume as much as a fridge that's 3 or 4 times bigger than it. Usually 10 to 15 cubic foot is a good size. Prefer chest freezers to upright freezers. Don't buy your fridge for the biggest party you'll have at your cabin. Just bring separate ice boxes and fill them with ice for temporary use. Now some usage advice. Obviously, keep the door closed as much as possible. Add thermal mass. So for example, some water bottles that'll keep the cold in the fridge. Maybe even if your battery runs out, your fridge will stay cold longer. If you have hot food, let it cool down before you put it in the fridge. And the most important one, avoid using your fridge or freezer in winter. The solar production in winter is really low, so you don't want to use this to run a freezer in your cabin when you can store your food outside in the snow. Now let's talk about the kitchen. In the kitchen you have a lot of things that require heat. Your electric water kettle, electric coffee makers, electric toaster ovens, microwave ovens. All these things draw a lot of power and a lot of energy. If you have a powerful system and big batteries and a powerful inverter, you can run a coffee maker or a toaster oven for a couple of minutes, but ideally, if you can avoid it, you should go for propane-powered alternatives, or ideally heat water up on your wood stove. And never ever use an electric heater run by a solar system or a generator. So for all the devices that I haven't mentioned yet, or the devices where you don't know and you want to go more into detail, how can you find out how much energy or power they consume? There's a couple of different options. Usually it's written on the back of the device. If you look at the nameplate, somewhere there should be written what the wattage is. Sometimes it's only written the maximum wattage, so the device will use a bit less. It won't always use as much. So in this case, there's another option. You can look on the internet what this device on average uses. This is one option. Or you can go more into detail by using a plug energy meter. This is this device here. So you plug it into an outlet and then you plug your device into it, and instantaneously, if you use your device, it'll show you what the wattage is that it uses. And for a toaster, once the toaster is turned on, it's always the same amount. But for example, a laptop charger can vary depending on different factors. Or a fridge has a compressor that turns on and turns off at different moments, depending on the temperature outside and how often you open the door. So what you need to do there is not look at the wattage, but look at the kilowatt hours that it uses over a period of 24 hours. If you have this information, you can put it into our Excel sheet and have even more precise calculations. How do you get this calculator? You can go to our website, which is either fnqlsdi.ca or iddpnql.ca, and then you can go to the English version if you're not already there. And then in the search field, you can just enter energy, and the article shows up. Down here, you can download the Excel file. Once downloaded, you can open it. And down here, you'll see different tabs. The first is a couple of instructions of how to use it. And the second one is the first one that is important. Here you have different devices listed that you typically have at your cabin. This column indicates the quantity of the devices you have. And then here in this column, you enter how many minutes or hours your device is running per day. Let's take an example. Let's say we have a Energy Star 120 volt fridge. As I said before, it's cheaper, but it'll use more energy. Then let's say we are using a range hood fan for 20 minutes per day. Here I can change minutes to hours if I need to. Then let's say we're using a laptop for, let's say, one laptop for, let's say, 4 hours. And I want to surf the internet, so I am also going to need satellite internet, also 4 hours. Keep in mind, satellite internet uses quite some power, so turn it off if you don't use it. And let's say I'm using 4 light bulbs for 6 hours per day. All right, good. So since I have a fridge up here that runs on 120 volts, I need an inverter. The inverter takes the battery voltage, which is usually 12 volts or 24 volts, sometimes 48 volts, and it brings it up to 120 volts so I can use my domestic appliance. And I'm going to choose a high quality inverter here because it's on all the time, because it needs to run the fridge at any moment. So inverters have standby consumption. They consume energy in the background. And you see that this high quality inverter will use less energy in standby than a low quality inverter. Let's look at this. Here you can see that the low quality inverter might use as much power as the fridge itself. So it's really important to pay attention to this. Now we get our energy usage, and that allows our little program to calculate how much solar power and how much batteries we need. Keep in mind, these are approximate calculations. Your life is never the same, and neither is the weather. And usually the rule goes that you always have too much solar energy in summer and not enough in winter. So our calculator shows us that we should use at least 1200 watts of solar with the devices we have entered. And this is for a 3-season cabin if you don't go that often. If you live at your cabin full time and even in winter, then you might use more solar. Down here you have the battery capacities. The first one is in watt hours, and it's what you use for portable solar power stations. If you're building your own system or you're having it built by a solar supplier, here are the amp hours that you need for lithium and for lead acid. If you go with a higher voltage for your system, you need less amp hours, but you'll see that the batteries you actually need are the same. Okay, that's it for our solar calculator. Let's get to solar panel installation. First, ideally, you want to have your panels face south. This is where the midday sun is, and the midday sun is the strongest. Of course, we want to capture the sun when it's the strongest. For all season use, so if you use it also in winter, you want to optimize your panels for winter, because in winter you have the least solar yield. We recommend a 60-degree angle, so it's facing the midday sun in winter, and it allows the snow to fall off. Here you can see a panel at 60 degrees. And you can also see, which is also important for winter, that the back is accessible. We've talked about bifacial technology, and this is where it's really important. So let's say in winter, even when you have snow accumulation, that happens, even if the panel is completely upright, there will still be some snow that sticks to the panel. In this situation, if you have snow on the front, with a bifacial panel, you still have the reflection from the ground. The light is reflected and gets to the back of the panel, and it'll produce a little bit of power, which also heats up the panel and helps the snow melt. So bifacial panels are really working well in winter, up to 50% more energy yield in winter. In summer, it's not that important because in summer the sun is higher in the sky, it's in the sky longer, so you have 3 to 4 times more energy in summer. You can put your panels south facing, you can put them at a flatter angle. Here in this case, up here, we have put them on the east and the west flank of the building just because the building was there. And this side is only used in summer. East and west orientation at a flat angle works fine here. Of course, in winter it won't work at all because at this angle the snow will cover it and we'll have no production in winter. Now we also need to find out where we can place the panels. We need places that have no shade, especially between, let's say, 10 o'clock in the morning and 2 to 3 o'clock in the afternoon. Solar panels don't work well if they have only a little bit of shade on them. So we want to choose the place where we have direct sun, no trees, no mountains, no buildings in the way. Sometimes that means that you'll have to go higher up to clear the tree line. My favorite method to find out if a spot is a good spot for solar panels is I stand on this spot and I look south. So in this case, this is a panoramic picture. So that means this is the east and this is the west. We can see it's the afternoon here. The sun is up there. We can see it's probably late winter, early spring. Snow is melting. So the sun's trajectory at the moment is probably somewhere here, going up there. And here we're at the afternoon. And keep in mind that the hours around midday are the most important. So from here to here, we ideally don't want to have any shade on our panels. So for this season, it looks okay. But if we go deeper into winter, where the sun is much deeper in the sky, maybe like this, we see that maybe around 1 o'clock in the afternoon, these trees are in the way. So we're losing precious energy. Maybe we should choose another spot for our panels, or we might have to cut the trees to optimize our solar yield. In summer, we don't really have a problem because the sun is going up, way up there, is high in the sky, and we'll have more than enough sun on our panels. There are mobile applications that can help you doing what I just did. You can install them on your phone, and they use the internal compass and the acceleration sensors. You look at your screen, and through your screen you can see the position of the sun. In this screenshot, it shows us the winter sun trajectory down here and the actual sun trajectory. And then the summer sun we can also see, but that would be way further up. It's really useful because here you can see a lot of things that happen. For example, here, even in winter, between 10 and let's say almost 2 o'clock, we still have sun. So that will be a good spot because of that. Then in spring and fall, probably we have a bit of shade on our panels in the afternoon. And then in summer, usually it's not that much of a problem. So these apps are really interesting, really practical. And there are different apps that essentially do the same thing for Apple and for Android. They are called Sun Position, Sun on Track, Sun Tracker AR, Sun Seeker, Sun Surveyor, and probably there are others. How can you mount the panels? The easiest solution I found are Z-brackets. They look like this. You can buy them online. They come with all the nuts and bolts that are necessary. And you bolt them behind the panel. The panel usually has holes in the frame. So here there will be nuts and bolts that hold us together. And then you put them on the roof and you screw them into the roof. The screws have washers made out of rubber that prevent the water to come in here. But keep in mind that underneath this bracket you still need to put caulking. Otherwise you get water infiltrations in your roof, and that's what you don't want. In winter you need your panels to be at a steeper angle. So probably your roof won't do. What you can do is build a wooden support out of treated lumber, for example, like this one. Although this one is a bit low, I would probably put it higher because you want your lower edge of the solar panels to be higher above the snow line, so there's no snow accumulation on the panels. There are also more professional mounting systems where you install rails on the roof and then you can clamp solar panels in larger quantities onto them, but these parts are harder to find. Then you have professional ground mounts. Usually they are made for 6 or 8 or 10 or 12 panels. So they are quite much more expensive. This one can pivot, so that's an interesting thing. You can pivot it this way, and here you see it in a summer orientation, so it's ideal for the summer sun. And here you can see a steeper angle, which is better for the winter sun, and it also helps to shed snow. And then you have pole mounts. These are even more expensive because obviously you need the pole, you need the structure to hold everything, and then of course you need a base made out of concrete to hold the thing in place. And then you have side of pole mounts, which are usually good for one panel. If you don't have a big system and you only want to run lighting, that might be an option. Let's talk about the solar system components. So if you have a custom built modular system, let's start with the battery. We'll start with the battery because that's the most expensive part. It's also the part that breaks the easiest and that doesn't last very long compared to the other components. So let's say we have the battery and we have the solar panel outside. In order to connect the panel to the battery, we need a solar charge controller. This device uses the energy from the solar panel and charges the battery with this energy. You can't plug in a solar panel directly into a battery. That'll break the battery because it will overcharge it. And then in the simplest case, you can already use the 12 volts from your battery. Just keep in mind, if you use light bulbs or other devices that don't have a low voltage protection, these light bulbs will drain the battery regardless of if it's full or empty, so that might break batteries. It's a really important idea to use a battery protector in this case. Let's say you don't have enough sun and you want to charge your battery with a generator. In this case, you need a battery charger. And then if you want to use 120 volts to run your domestic appliances, you need an inverter. The inverter takes the 12 volts from the battery and turns it into 120 volts. So in this case, you can see There's 120 volt plugs here where you can plug in your devices. Let's talk about the batteries. Lead acid batteries are the oldest kind of batteries. They have been around for a long time, and the simplest version of this are flooded deep cycle batteries. Deep cycle is important because from the outside they look like car batteries, but they are not the same. Flooded deep cycle batteries are made to store energy, and car batteries are only made to start your engine and then be recharged immediately with the alternator. So you need flooded deep cycle batteries. Again, you cannot use car batteries for your solar power system. They will break very fast. Believe me, I have tried. These batteries are fairly heavy, very heavy indeed, because there's lead in them. They are the least expensive, but you need to do maintenance on them, especially the flooded ones. They have these caps that you need to take off every couple of months to weeks and check the water level. And if you see the water level is too low, you need to fill up with distilled water. Look at the procedure maybe on YouTube and take precautions, because this acid is highly concentrated. It can burn your eyes, it can burn your fingers. You should wear protective gear. One major thing with lead acid batteries is they are not intelligent, so it's very easy to break them. If you discharge them too far, they will easily break and lose capacity, and you don't see this from the outside. So a lot of batteries are broken, they lost all their capacity, and people are wondering why their solar system isn't working well. It's most of the time because of the batteries. Then there's lead acid batteries that don't have any caps. They're called sealed lead acid batteries or AGM batteries. They are as heavy, they are a bit more expensive, but you don't need to do maintenance. Other than that, they can break as easily if you don't charge them well. Lead acid batteries like to be charged to 100% as much as possible. Lithium batteries have been around for a couple of years. It started with phones, and now we have power tools, and we even have cars. So they are used pretty much everywhere. And there are also some interesting solutions for off-grid solar power systems. They are much lighter than lead acid. They are more expensive, although this difference is shrinking fast, especially because they last longer and they are more powerful. So depending on how you calculate, they might even be cheaper than lead acid batteries. They have an integrated intelligence, a so-called battery management system, and this battery management system will protect the battery from all kinds of harm: overcharge, undercharge, over temperature, low temperature. But keep in mind, if you discharge your battery and you leave it on a shelf, the battery might break. This is pretty much the only way to break a lithium-ion battery. One major caveat is the behavior below 0 degrees Celsius. The batteries can't be charged below 0 degrees, and they can't be discharged below minus 20 degrees Celsius. All batteries hate the cold, they don't work really well. Lead acid batteries also work really badly in cold weather, but lithium batteries can be damaged, so they protect themselves with the BMS and shut down. This is something to keep in mind. Although now there are heated models that use the solar power to heat up the battery before it is charged, so that mitigates the problem to a certain point. Lead acid batteries and lithium batteries should both be kept in insulated containers so that temperature doesn't drop too much in winter. There are different sub-variants of lithium batteries, and the best one we use for off-grid solar is lithium ferrophosphate or LFP batteries. You'll see these are pretty much the only ones that you can buy for off-grid solar setups. These batteries are a little bit heavier than normal lithium batteries, but still 4 times lighter than lead acid batteries. They have a longer lifespan, so they have more charging cycles. That means I can charge and discharge them more often. And they are also safer than normal lithium batteries. All in all, LFP batteries have big advantages over lead acid batteries, except when it comes to low temperatures. Now let's talk about inverters. Inverters convert 12 volt from your batteries, sometimes also 24 or 48 volt, into 120 volt AC, so you can use your domestic appliances. What's important to look out for are true sine wave inverters. Older inverters use a modified sine wave, and these can really break compressors and motors, and you should not use them. Usually the inverters are pretty efficient in their conversion rate, but watch out for bigger inverters. The bigger the inverter is and the more powerful it is, the higher the standby consumption usually is. And if your inverter is supposed to be turned on all day, for example, to supply a fridge, then the standby energy consumption is really important. Another thing to watch out for is noise. Inverters usually always have built-in cooling fans, and these fans can be a bit annoying especially when you plug in high power loads. Consider selecting an inverter that's not noisy, or try to install it in a place away from where you sleep. Now I want to introduce a simplification that's very common. Instead of having one inverter and one battery charger, you can have a so-called inverter charger. This device does three things. First, if you're running on battery power, it of course can supply 120 volts to your devices from the battery. Then, if your generator is running, it can of course charge the battery, but at the same time it will divert power from the generator to supply all the devices with electricity while the battery is charging. If you want to build your own solar power system, I recommend to start small. When you build a bigger system where you have to work with inverters, you will have to work with 120 volts, which is dangerous, and you should do it. You should leave this to your electrician. But you can practice yourself with a system like this. A 12 volt system that uses a cheap battery, which is around $200, then a solar panel that is maybe around $130, a couple of car fuse holders. These are 12 volt light bulbs that are directly fed by the battery. Actually, not directly. They use the output of the solar charge controller, so that also functions as a battery protector. And with this you can light your cabin, and you can also install a USB charger, so you can charge your phone. You can do a lot with this. It's an easy start and it doesn't break the bank. I also want to show you some solar power systems that we have installed in real life. This one is installed at the kitchen at the Matakan side. This is a close-up. Here we see the inverter here. This is what we call a bus bar, basically where all the cables come together. This is one solar charge controller, and this is a second charge controller. As you can see, these brands are different, which is possible in a modular system. You don't have to buy everything from the same brand. This system also powers this fridge, which is a 12 volt fridge. You see the batteries here, which are big AGM batteries. Then you have a charger here to charge the system with a generator. And back here you have the fuses or the breakers, and the cabling is hidden behind this panel, and here you have an energy monitor, which is important. This is a more high-end system using lithium batteries. So here you see the batteries, you have a main fuse, you have a battery monitor, here you have the bus bars that bring all the cables together. This is the inverter charger, and the blue cables here are input and output AC. So we can charge it with a generator, and we can use 120 volts, and we can plug this into our panel. When I say we, I mean, of course, you should get an electrician for that, because it's dangerous handling 120 volts. Here we have a solar charge controller, and the panels are outside. In this case, it's only two of them. It could be more, probably, for a setup like this. This is what the system looks like in real life. And this is in the process of assembly. What we see here is a concrete panel. Behind the concrete panel is a plywood panel, so the screws can grip, but the concrete panel is important for fire protection. And that's it. I hope you have learned a lot. Don't hesitate to send us any questions, and have a good day.